Hello and welcome, everyone. We are thrilled to have over 1,000 people registered for this event from over 333 institutions across industry, government, and academia, located in 36 different countries around the world. And it is our honor today to feature two of GRC's longtime loyalists, Harry Gray and Rich Eisenberg, who will speak about innovation by inorganic chemistry. And I'm also pleased to welcome Cara Bren, who will introduce our speakers and serve as moderator. Cara earned her BA in chemistry from Carleton College in 1991 and her PhD at Caltech under Harry Gray's supervision in 1996. After a postdoc at UC Davis, she joined the faculty at the University of Rochester, where she is a professor of chemistry. Her research program involves investigating new methods for engineering metalloproteins in the cytochrome C family. Cara is a fellow of the American Association for the Advancement of Science, a Kavli Fellow of the National Academy of Sciences, and associate editor for the Journal of the American Chemical Society. She is also the chair of the 2022 Metals in Biology Gordon Research Conference. Cara, thank you for joining us. And I'll ask you to turn on your camera and your microphones and introduce our guests.
Thank you so much, Nancy. I'm really happy to be here and be part of this GRC Connects series on innovation by inorganic chemistry. So today I have really quite an easy job of introducing two scientists who need no introduction, Harry Gray and Rich Eisenberg. So I do want to share with you some of their accomplishments during their long careers. So first, Harry Gray is the Arnold L. Beckman Professor of Chemistry and the founding director of the Beckman Institute at Caltech. His career goes back to the early 1960s, where he started at Columbia before moving to Caltech. And in his career, he's played a central role in many different aspects of inorganic chemistry, developing ligand field theory, inorganic photochemistry, biological inorganic chemistry. So his work has influenced the development of light absorbers and photocatalysts for solar fuels, our understanding of the relationship between metalloprotein electronic structure and function, and understanding electron transfer reactions. He has received many awards and recognitions, just a few of which are the Priestley Medal, the Cotton Medal, and the Richard Feynman Prize. He's been elected to the National Academy of Sciences, the American Association for the Advancement of Science, and holds many other honorific positions. He also was the chairman of the Board of Trustees of the Gordon Research Conferences in 2000. So one of Harry's most famous students is also joining us, in Rich Eisenberg. So Rich is the Tracy Harris Professor Emeritus at the University of Rochester. His independent career also goes back to the 60s, to 1967, when he started at Brown. He then moved to Rochester in 1973, where he remained throughout the rest of his career. So in recent years, Harry's been known for his work in photogeneration of hydrogen from water using systems based on earth-abundant elements. During his career, he's also been a leader in investigations of luminescent complexes for photoinduced charge separation, parahydrogen-induced polarization for hydrogen addition reactions, and the design of electrophilic catalysts for organic transformations. His work's been recognized by many awards, including the ACS Award for Distinguished Service in the Advancement of Inorganic Chemistry, and the ACS Nobel Laureate Signature Award in Graduate Education, which he shared with his student Ping-Wu Du. He's a fellow of the AAAS, of the American Academy of Arts and Sciences, he's a member of the US National Academy of Sciences, and he served the community in many ways, just a few being that he was editor-in-chief of the journal Inorganic Chemistry and chair of the Gordon Research Conference on Organometallic Chemistry. So with that, Harry and Rich, we are all really looking forward to hearing your talk on inorganic chemistry, tackling big problems the GRC way. So Rich, if you can share your slides.
Okay. Rich, are you going to share your slides?
I hope so, Harry. I hope we get there. I'm going to start my video too.
Okay.
And we will be ready to go very shortly. Let me see if I can find this. There's a start my video. No, we'll get there. It all works in practice.
Don't worry, Rich, I can talk without slides.
There we go.
Okay, here we go. And
Okay.
you should be up, Harry.
All right, everybody, let me move my little video thing over so I can see the full screen. Okay, now I've done that. Well, welcome everyone from 36 countries. I'm sure there are lots of folks out there who know me and lots of friends and a lot of people who probably don't know me, and you'll get to know me a little bit in the next few minutes. And I'm anxious to communicate with all of you, and I hope you all have lots of questions for Rich and me at the end of this. We're going to talk about the role of the Gordon conferences in inorganic chemistry and biological inorganic chemistry and organometallic chemistry and solar fuels during this presentation. I'd like to start in the 1950s when I was a student and I encountered this paper by Ron Nyholm at the time when I was an undergraduate and I was a synthetic organic chemist. Most people don't realize that I started life as a synthetic organic chemist, but was converted shortly thereafter. One was Ron Nyholm's famous paper on the renaissance of inorganic chemistry. He pointed out what I already knew, that inorganic chemistry in the 40s and 30s was dull and interesting. It was a collection of unconnected facts. It wasn't rigorous. There was no system. All the problems were dull. And in fact, the only thing I really knew about the field was I knew all about the manufacture of sulfuric acid. And so I said, this is not for me. I'm going to be a synthetic organic chemist. But that all changed. Next slide, Rich.
Okay.
That all changed in the 50s when the Gordon Conference on Inorganic Chemistry was started in 1951. Of course, I didn't know about this. But what happened in this period was three people made a huge impact. Henry Taube in inorganic mechanisms, and Jeff Wilkinson in organometallic chemistry, and Leslie Orgel in theory and electronic spectroscopy. And when I joined Northwestern as a graduate student to continue my work in synthetic organic chemistry, which I'd started in research as an undergraduate at a small college, I went to a seminar in the fall of 1957, and one of the inorganic chemists at Northwestern, Pierce Selwood, strode into the seminar room and said, I have an announcement for everybody. We have finally, in inorganic chemistry, removed the shackles that the physical chemists have placed on us. We now have our own division of inorganic chemistry. Just a few weeks ago, it was announced. Now we no longer have to take orders from these physical chemists. We're our own people. And so that was so striking to me as a first-year graduate student. I said, hey, I'm going to change fields. This field looks pretty cool. So next slide. I started looking into things. I read Henry Taube's chemical reviews paper, in which he actually for the first time explained the lability and the inertness of various metal complexes. And this case in terms of Pauling, Linus Pauling's valence bond theory of inner and outer orbital systems. Later, of course, it was explained perhaps better by crystal field and then by ligand field theory. But Taube was the first to really make reaction chemistry of metal complexes pretty well understood. And so this energized the field. And then Jeff Wilkinson, next slide, Rich. Jeff Wilkinson, I read his paper, and Jack's 1952. Wilkinson and his co-workers at Harvard had seen the paper by Keeley and Pawson, who'd synthesized ferrocene. They didn't call it that at the time, but they had synthesized bicyclopentadienyl iron. And the upper structure there is the one they proposed. It was a 2-coordinate structure, which Wilkinson was pretty sure had to be wrong. And so Wilkinson and his co-workers, one being R.B. Woodward, a slightly known organic chemist, proposed this famous sandwich structure in this paper based on measurements they had made. And this turned out to be right and really propelled the field of organometallic chemistry. Next slide. This structure was confirmed by X-ray crystallography. And I draw your attention to the one that was done at Caltech when Jack Dunitz, Leslie Orgel, and Alex Rich were all together at Caltech. Dunitz and Orgel were visitors of Linus Pauling's, and Alex Rich worked for Pauling. And Pauling let them have a crack at this crystal structure, and they did it and showed that ferrocene is in fact the sandwich complex that we know and love today. And that made a huge difference in the field and propelled it forward. In the next slide, I give you a little hint about crystal field theory and spectra. Again, that was Leslie Orgel and others, Scandinavians and Germans and others. But Orgel really was the guy who explained it all to inorganic chemists in terms that we could understand. And he wrote a paper, again, when it was visiting Caltech, the bottom paper he wrote, a famous paper called Spectra of Transition Metal Complexes, which for the first time really explained the green color of nickel ion in aqueous solution, the pink color of cobalt-2 octahedral, and the blue color of tetrahedral cobalt, and so on. And so this really took hold, and inorganic chemists came in droves. In fact, the next slide shows another big advance in the 50s. Bill Malmström in Sweden and R.J.P. Williams in Oxford wrote many papers in the role of metal ions in biology, and inorganic chemists give them credit for the origins of our field of bioinorganic chemistry. But in fact, Kara and Rich and I have written a paper in PNAS giving the credit to Linus Pauling. You can read our PNAS paper there. Linus Pauling and Coriell in 1935 measured the magnetic susceptibility of oxy and deoxyhemoglobin and showed that when oxygen binds, the thing goes low spin, and suggested the first kinds of electronic structures, which we reviewed in this PNAS paper. So if you want to read more about this, we would love it so we can get a few more citations. Anyway, many young investigators really joined up in the field in the 60s and 70s in bioinorganic, and that of course led to the Gordon Conference. And here's the Hall of Fame from that period, just to show you a few people. I'll start in the lower left with my boss, Fred Basolo, because after I had heard that announcement from Pierce Selwood that we had our own division, and I decided I was going to join up and abandon synthetic organic chemistry. I went to Fred Basolo, and he was charismatic and showed me, told me about the Gordon conferences and inorganic chemistry and how they were great. And if I joined up, I could probably start going to them. They would probably let me in. So, and he gave me a project to work on in platinum chemistry, and we joined forces. And then in his course, he taught me about Wilkinson's work, about Baylor's work, about Leslie Orgel's work, about Bob Williams's work, and about Henry Taube's work. I learned all of these lessons from Fred Basolo in the first course I had ever taken in inorganic chemistry. Let me explain this. In the 1950s, in small colleges, there were no inorganic chemistry courses. It was not a field that was taught in small colleges. It was taught in a few big universities like Northwestern, but not in small colleges. So when I was an undergraduate, the only courses available to me were physical chemistry, organic chemistry, and analytical chemistry. And so I took lots of advanced physical chemistry. I took advanced analytical chemistry, but I didn't know anything about inorganic chemistry except what I'd done myself in my lab making compounds. And so Fred taught me all of this stuff with these wonderful folks who'd made such great contributions. And then, ladies and gentlemen, there's the famous Al Cotton in this photograph. Al and I went to my first Gordon conference in 1962, where I met Al Cotton. And Al Cotton and I went to every inorganic Gordon conference in the 1960s, and we bonded over one issue. If you go over to Henry Taube, for all his greatness, was on the Committee on Professional Training in the ACS, and he missed a couple of meetings. And when he missed a couple of meetings, the physical chemist and organic chemist voted to get rid of the inorganic course as a requirement for graduation with a certified chemistry degree. And Al Cotton and I found out about this at the Gordon conferences. And we teamed up, and at all the inorganic Gordon conferences, we recruited all sorts of young people to go to ACS meetings and beat on the Committee on Professional Training to get our course back as a required course. And we succeeded. And this is the reason that at the national ACS meetings, the biggest program is inorganic, because we energize the inorganic chemists to go to ACS meetings and present papers and lobby the Committee on Professional Training. So finally in the 70s, we got our course back as a required course. So Al Cotton and I became friends. We've had off and on relationships over the years, but Al Cotton did an enormous amount for our field. And it was through a lot of his participation in Gordon conferences. So let's move on, Rich. To the next slide, if you can make it.
No, I can't.
Rich, you seem to be fixated on this slide.
I like Al Cotton. Go ahead, Harry.
Well, you probably wanted to hear more about Albert Einstein, who was over there with Henry Taube. I want to talk about Bob Perry. A great thing happened in our field in 1962. One of the great loyal inorganic Gordon Research Conference persons, in addition to Fred Basolo, was Bob Perry, who's over there in the upper left, next to the nice yellow Inorganic Chemistry journal, which he started in 1962. Another enormous advance in our field to show how the field was exploding at the time and in all sorts of areas, and young people were joining in droves. And so we needed our own journal. So Bob Perry started it. You can see how he's over there with Fred Hawthorne. And I guess actually Fred Hawthorne succeeded him and worked with Herb Case and Ted Brown and Mel Churchill down below in the right, you can see Herb Case and Fred Hawthorne, who worked together on the journal. Fred was the editor. And then Fred finally decided we needed young blood in the thing. So he turned the thing over to my friend, Rich Eisenberg. And Rich Eisenberg, you can see there with Bob Perry. Bob is holding the journal I like, the yellow one. And Rich, of course, had to put his stamp on it. So he had this ugly looking thing he's holding, changing the cover. And so I had to get used to that. But after 5 years, I decided that was probably okay. And then after Rich served the journal, which he did with great distinction for many years, and he built up the journal into a fantastic journal. Then he gave it up, and Bill Tolman, who's over in the lower left, a great inorganic chemist, took over, and he's the editor to this day. And Bill has also done a wonderful job of soliciting papers from all over the world at the frontier of inorganic chemistry. This has been a fantastic advance in our field, this journal. So in the next slide, I will start with the first Gordon Conference, which already was mentioned in the video, but there it is. And you can see what we've said about it. It was a bunch of men, actually, who were well-dressed in suits and ties and very geeky, of course, and from academic industrial labs and living in, the first one was at New Hampton School. Well, I can tell you, I went to all the ones in the 60s, and I'll tell you, the beds are very short and they're very hard. It's almost impossible to sleep in the New Hampton School because, but we described that as living in New England prep school luxury for a few days. I challenge you to find any women in this slide, although there is one. There was only one. But boy, have things changed. Put on the next slide. Here is the 2016 Inorganic Conference with the women have, fortunately, have flooded the field, entered the field, and done enormously great work in the field. And here's a photo that they took in the 2016 conference. There were, of course, a few men there, but the women got together for this lovely photo to show you that things have really changed. The Gordon Research Conferences have gone from no diversity to a really very substantial diversity. And so that I applaud greatly. I think we've come to a point now where we're really mixing up the way we should have been doing a long time ago. And so now I'm up to the Gordon Conference that Kara is involved in and I've loved for years. But it was started in 1962 and it was called Metals and Metal Binding in Biology. And there were no inorganic chemists, 0 inorganic chemists at the first meeting. The folks that you see in this are medical types. A lot of people who were in nutrition, human nutrition. Paul Solomon called them pig feeders because they would feed pigs with trace metals to see how trace metals affected human health. But Paul Saltman started coming to this meeting, and by 1968, the conference, Paul Saltman liked inorganic chemists, and he knew inorganic chemists would have something to say about this. So Paul Saltman invited inorganic chemists to start coming to the conference, and Jack Halpern and Dick Holm and I came to the 68 conference with Paul's invitation to come. And then Dick and Tom Spiro. It was really Paul and Tom Spiro and Dick Holm and I then rounded up a lot of inorganic chemists. So we really invaded this field, and the pig feeders didn't like us, and so they departed. And so the inorganic chemists and the biochemists and molecular biologists took over the field. Paul Saltman was a great guy, and a great Gordon conference guy. He would sit in the front row and greatly encourage the young investigators, but he'd make fun of all the old investigators, the senior people, and make them mad. But he was a great guy in the Gordon Research Conference in Metals and Biology. He really energized it. So by the time I took over the conference, and next slide, in 1982, I was the chair. The conference, there were no pig feeders left. There was about equal numbers of inorganic chemists, biochemists, and molecular biologists. It was really a really diverse group, and now the inorganic chemists had really made their mark in the field, and that's continued to this day, and I'm sure it will be true in Kara and your conference that's next time. So what's happened in the field? Next slide. Well, our field, I'd like to say modestly, involves the most important reactions on planet Earth. We can brag about the things that we work on, photosynthesis and water oxidation and the manganese, calcium's OEC to oxygen, and respiration, oxygen reduction by cytochrome oxidase, and mitochondrial respiratory system. We work on nitrogen fixation catalyzed by FeMoco and nitrogenase, and we work on alkane oxidation, a whole number of enzymes, including cytochrome P450. And so our conference over the years has made enormous strides in understanding the structures and the reaction mechanisms of these four really major reactions in bioinorganic chemistry. And so on my final slide, Rich, I will present some highlights in the field from 1968 to the one that we couldn't have in 2021. I'd like to say it, first of all, I put the bullets here, but I have no names on this because I'd like to say that we have an international audience, and I'm very proud that these the advances have been made by investigators literally all over the world. And in North America, in Asia, in Europe, Australia, all over the world, people have come to our meeting and presented work on the structures of metalloenzymes, for example, cytochrome oxidase, nitrogenase, photosystems 1 and 2, the famous reaction center in photosystem 2, the calcium manganese cluster, FeMoco and nitrogenase. All of these have been discussed extensively, sometimes presented at our conference. And there's been a huge advance in understanding metallocofactors, not only through synthesis by a whole group of very talented inorganic chemists from all over the world, and electronic structures and spectroscopy of these metallocofactors. So much so that the metallocofactor Gordon Conference split off, and there's now a separate metallocofactors Gordon Conference. And during this time, radical enzymes were discovered, and their structures and their reaction mechanisms were worked out. In fact, there was once a radical enzyme, separate radical enzymes, Gordon Research Conference, but it was probably way ahead of its time before so many radical enzymes were discovered, like the radical SAMs. And so it was discontinued. So the discussion of these enzymes have really been part of the Metals in Biology, GRC. And then there's been a lot of work on biological electron transfer, electron tunneling and hopping, explaining for example, the long range events in radical enzymes like ribonucleotide reductase. And in fact, the mechanistic discussions have dominated many of the conferences. And and oxygenases and reductases and all kinds of metalloenzyme mechanisms and many more. These are just a few of the highlights. But another highlight, and I'll finish with this, is the passing of the torch. In the lower right, there's always a highlight of our Metals in Biology conferences is when one chair receives a certificate, as you see in Joan Broderick receiving her certificate from Jim Mayer. Her certificate is chair of the 2014 conference, and she's passing the torch at this time to Jim Mayer, who chaired the 2015 conference. That's always a highlight of our conference. So that's my story to date. I'd also like to say there are other Gordon conferences related to inorganic and metals in biology that have split off during this time, including inorganic reaction mechanisms and metals in medicine. We have discussed metals in medicine at our conference, gold, platinum, and ruthenium drugs. But now that's a separate conference called Metals in Medicine. So the point I'm making is the renaissance of inorganic chemistry led to first to the inorganic conference, then to the metals in biology conference, and now a whole series of inorganic related conferences. And so we are a very big footprint now in the Gordon Research Conferences. And I'm very proud of what we've accomplished in this field and all the international participants who have contributed so much to our field. So I'll now turn this over to my brilliant colleague, former student, who's retired. He threw in the towel. You see, I can say now that I'm still active, and most of my early students have already retired. So I'll turn it over to the retired Rich Eisenberg, who still knows a little bit about the field, to continue this discussion. Rich, it's up.
Okay, thank you, Harry. And in the few moments I have left, let me go through organometallic chemistry because, but I'm not going to start with the first organometallic Gordon conference. And instead, I'm going to jump to 1988, which was the year that I chaired the Gordon conference. It was the second year we were in Salva Regina. You've got this beautiful mansion, Ochre Court, behind us. And there I am with a little bit more hair, but it was disappearing. And to one side of me is you have Tom Baker and Henry Brinza, the co-chairs. Over here you have Bob Crabtree and Jack Halpern, David Milstein. I think this is Lou Hegedus. And what I think was interesting, though, and we worked very hard at getting a dynamic program, a program of new chemistry, new science. And in this group were two Nobel Prize winners before they won the Nobel Prize. The first one of these actually is in this little slice from the picture. By the way, this is the young Cliff Kubiak here. I think Hillhouse and Wolzansky might be here. Tom Katz there. But the person, Lenin Tarante, but the person I really wanted to focus on is Ryoji Noyori. And he was talking about some work that he was doing at the time, which involved asymmetric hydrogenation. And basically, he had come up with this chiral diphosphine ruthenium complex and found that one could do asymmetric hydrogenation. It turns out that Noyori's work and work as well by Barry Sharpless and by Bill Knowles, and this is Bill Knowles' work here, which is again asymmetric hydrogenation that led to the production, the synthesis of L-DOPA. Barry's work was in asymmetric epoxidation and dry hydroxylation chemistry. But this was very exciting new work before it had been recognized. Let's go back to the conference again. Who was the other person who was amongst this group? Well, it turns out it was this tall guy in the back here, Dick Schrock. And just a few years later, Schrock was part of a Nobel Prize group that included Yves Chauvin and Bob Grubbs, could have also included Tom Katz, for olefin metathesis. And this was inclusion of Dick Schrock in the program before they were recognized as having done something spectacular by Nobel standards, but at a time when we recognized that it had been. So here's the olefin metathesis reaction. Schrock's particular contribution was the first alkylidene complex. And it's this motif over here, the metal double bond carbon, that was really the key and allowed it to do chemistry similar to what one might have done in a Wittig reaction. But I think Schrock helped change the nature of how we viewed metal carbon bonds. Now, in terms of the mechanism of olefin metathesis, let me just start with the metal alkylidene. So here's carbon. You have an olefin, you form a four-membered ring. And then you are able to eliminate two of the carbons as an olefin. You now have another alkylidene. Take a second olefin, you form another metallocyclobutane, and then, of course, you eliminate what is the product here, which is the olefin that you did not begin with, and around and around. And what Bob Grubbs did brilliantly shortly thereafter was realize that you could take a cyclic olefin, cut it right here, and get ring opening metathesis polymerization. Both Bob and Dick Schrock and many others have been involved in that brilliant chemistry that was done. If we go back here, though, we now also have a number of other people. And let me point out a few folks here. This is John Burkhaw, Hans Brinzinger. They are interested in making inroads in polymerization catalysis at the time. This is the young Steve Buchwald. He was beginning his career at MIT. There are two other people I want to point out here. One is Bob Bergman. I also should point out, here's Jay Kochi, who is very important in terms of the mechanisms of organometallic reactions. Here's Bob Bergman, and here's my colleague, Bill Jones. And what were they doing at the time? Well, they started to look at carbon-hydrogen bond activation chemistry, and they did some simple reactions with iridium and reactions as well with rhodium in terms of the cleavage of unactivated carbon-hydrogen bonds. And one of the brilliant pieces of work that Bill Jones did during the 1980s involved the thermodynamics. Here, if you have an alkyl CH bond and an aryl CH bond, this one is the stronger bond, the aryl CH bond. This is weaker, relatively speaking. But Bill was able to explain why the metal aryl, or why the carbon, the aryl CH bond, in fact, is activated more easily through this kind of interesting thermodynamic study. From olefin metathesis, there were other developments that were going on. This is my good friend, Maurice Brookhart. And I don't know, he doesn't wear a tie most of the time. And Alan Goldman. And part of the a program that was set up by NSF, the Sensi program. And they did something called alkane metathesis, which combined olefin metathesis with carbon hydrogen reductive elimination. So you could go from alkanes to alkenes, and then you could go through the olefin metathesis reaction to other alkenes, hydrogenation back, and now you had new alkanes in the process. This was done with new iridium compounds that Alan and Brooke were studying. This was interesting, new, and innovative chemistry. I should mention as well that during the time that what was going on in their work, there were other things that happened over the ensuing period of time in terms of catalysis by 3D or metals. There were materials and material precursors that were made. There was redox and odd electron chemistry that was done, with photochemistry, many, many different avenues that were studied. But there was also chemistry that was taking place in terms of CH activation that had a very different perspective, a more biological perspective. One example of this comes from the copper methane monooxygenases that Amy Rosenzweig had looked at. And so you are cleaving the carbon hydrogen bond of methane, but doing it in a totally different way. There's a way that the Gordon conferences allow people to discuss this kind of science, the two different approaches, and how one can enrich the other. Or let's take CH activation done in a slightly more complex way on alkanes, an example by Jay Groves with a manganese porphyrin type compound. And this is called a radical rebound mechanism. So the radicals were involved, it was multi-step. And again, you're doing CH bond activation. Now, what's the best way to get scientists and active researchers to discuss these different approaches to the same problem of CH activation? We don't just work in our own laboratories. We get together, but I think ACS meetings and large meetings, not the best way to do it. It's Gordon Research Conferences that allow us to get together, that allow us to have these talks, but it's also Gordon Research Conferences that allow us to have informal discussions. I omitted one for right now, and let me just mention it because she's a very dear friend of mine, which is using organometallic chemistry to mimic biology. And these are hydrogenase mimics that Marcetta Darensberg has worked on. And again, we're going to come back to some of this chemistry, but it's important work that ties the biological side to the organometallic side, the modeling of that organometallics can give you with the actual systems that biology does. So GRCs can bring together researchers from diverse fields to stimulate new approaches to these challenging problems. Now, once the talks end, once we've heard the formal presentations, the thing that makes the Gordon Research Conferences unique and why I urge you all, particularly young people, to attend the Gordon Conferences is what goes on after the evening session in terms of there's very active poster presentations, as you can see, lots of people, lots of discussion. But the meetings go on, and the meetings end, the evening session may end at 9:30 or 10 o'clock, but these discussions go on well into the wee hours. And it continues for 4 or 5 days. You can go to a Gordon conference and feel great when you go. By the time you get back, your mind is invigorated while your body needs a few days worth of rest. Because what happens is you sit around and you talk with people. This is an example of that. And you talk about science. At midnight, you have pizza, and you're talking about chemistry, you're talking about science, you're talking about different approaches. This is a marvelous way to do science, and it's unique. Think about it, guys. There is, and women, there are no other conferences at which scientists talk, interact, and discuss science for hours after the evening sessions end. This is why Gordon conferences are unique. And I would say sometimes it gets a little silly. A lot of times there are jokes. If you go in the lower left corner here, you can see Russ Hughes and Maurice Brookhart, Bob Bergman, myself, Jack Norton, and Bill Jones. We're all former chairs of this Organometallic Gordon Conference. Bob Bergman has a silly wig on, which he put on, and that's okay too. We laugh. And but the point is that these kinds of informal discussions, this is or can be where collaborations begin. The Gordon Conference is a great place to renew old friendships and to bring researchers together without the rush of a schedule. I put up two photos that are important here. The first one is one of my golf outings. By the way, the Gordon Conference did not improve my golf, but I had fun anyway. And this is with John Fackler and Bruce Burston, Al Saddleberger. And at that point, Fred Basolo was not playing golf anymore, but it was a chance for us all to get together with 3 or 4 hours to discuss life, liberty, the pursuit of the golf ball, and the pursuit of chemistry. And I remember Fred saying after we all shanked a shot, he said, "You guys are making a simple game look tough." Second picture I wanted to show was of these two guys, who I hope most of you know, Cliff Kubiak and George Stanley. They are both former GRC conference chairs. I want to thank George especially for the photos. Both of these guys, by the way, were undergraduates in my laboratory my first year at Rochester, and it's a long, involved story, but I have close ties and fondness to everything that they have done since. Now, I want to turn attention in the last few minutes to what I think is one of this century's greatest challenges, which is solar energy conversion. And what I put up here is the photosynthesis Z-scheme. It's not a very beautiful presentation of that, but I put it up here for a reason. This is the redox scale, and the Z comes out of the fact that there are 2 photoactive systems. There's an electron transfer chain, and this is sort of where the Z comes into play. In any case, this is biological photosynthesis. In 1978, I was at a conference in Cambridge, England. Al Bard was visiting and lecturing there. And Bard suggested a tandem semiconductor system that would mimic this Z scheme for water splitting and artificial photosynthesis. I found it very interesting. So did many other people. It was a beautiful model to work on. It had N-type semiconductors, and it still remains A, a great concept, and B, one that has drawn many people into the area of research on solar energy conversion. In fact, if we go to 2013, this is something that Tom Jaramillo published again as an idea. And now we have a P-type and an N-type semiconductor. There's work that other people have done, such as Nate Lewis and Dan Nocera and Harry, that ran this, who ran the Center for photosynthesis and water splitting at Caltech. The point is, we still have not achieved the practical goals on a scale that is workable for, let's say, splitting water into hydrogen and oxygen. Conceptually, we're getting there, and yes, we are moving forward, but this should continue to serve as a stimulus to new research and new perspectives. Let me point out, here's the Z scheme. I flipped it around. These are the two basic reactions here that one can talk about, but it's really water splitting that is involved in the Z scheme itself, in the energy storage. You don't reduce carbon here, you reduce actually NADP plus to NADPH. You can divide this up, and if you make this part, you can continue considering the catalysis for oxidizing water to O2. And if you take this part and divide and split it off, instead of making NADPH, you can put a catalyst here, take electrons that come from excitation by this light absorber, and take protons and make hydrogen from that. So you need electron source, and that would allow you to just study a single photosystem to do that particular reaction. So the light-driven water splitting, it's a multifaceted problem. It involves synthesis, it involves electrochemistry, it involves catalysis, photochemistry, mechanistic and computational analysis. And it's a major challenge that is best tackled via collaboration. And there is no better place to do that than through Gordon conferences. These are some of the questions if we tackle renewable energy in the Gordon Research Conference way, through collaborations, through discussion. What major elements of solar water splitting have not been achieved in a durable, reproducible way? What are the critical bottlenecks, light absorbers, catalysts for hydrogen evolution, oxygen evolution? Are molecular catalysts still relevant? Are hybrid systems the way to go? Theory, multi-component system design. Is the PV electrolyzer model the way of the future? This one gets rid of all the photochemistry I was talking about and just takes electricity generated from photovoltaics. I'm not sure I agree with that. Is hydrogen the way of future energy storage? What other systems could be used and in what ways? These are kinds of problems that are out there, and they are addressed best for most folks through collaboration and interaction. We do that at meetings, and there is no better meeting to go to than the Gordon Research Conference, and to tackle problems like that in the GRC way. So the Solar Fuels Gordon Research Conference, as well as other GRCs, address the many different approaches, features, and aspects of this 21st century challenge. And thank you. That's the end of my presentation here. Okay, so.
Thank you. Thanks, Rich. Thanks, Harry. So another aspect of the GRCs that I wanted to bring up and I guess ask you about, Harry, is the start of the GRS programs, which I think goes back to 1996, the Bioinorganic Graduate Research Seminar that was affiliated with the Metals and Biology GRC. And that was started up to give early career investigators, especially students and postdocs, more of an opportunity to participate. And Harry, were you involved in getting that started?
Yeah, I sure, yes, the answer. We were very frustrated, Cara, at the Metals and Biology GRCs, which were always oversubscribed, and we couldn't take even well-known investigators who applied too late into the conference, and we couldn't take any students or postdocs, young people, and that was very, very frustrating. So we decided to create something called the Graduate Research Seminar to kids to get together before, in our case, before the regular meeting for a weekend before, to have grad students and postdocs as the only speakers and have senior people be facilitators and discussion leaders and so forth. And this turned out to be, and I should have mentioned this during my presentation, that's an omission that I'm glad you you flagged, because it's one of the great inventions of the Metals in Biology Gordon Conference, and one of the things that we can take great pride in inventing, because this caught on like wildfire. And I think Nancy can tell us how many there are now, but I think there are hundreds of Gordon Research Seminars now connected to Gordon Conferences. So this gives young people a place to talk about unpublished work and their latest work, and get together and start on social media and collaborate and all kinds of things. This has been an enormous success of the GRCs, the GRS's, and so we're very proud of that. And I guess you say, I've forgotten which year it started, but it was, were you there at the time, Cara?
So I just started.
Were you involved in that? What's that? Were you involved?
No, I wasn't. I wasn't. So it started in '96, and I started my job here at Rochester in '97. So I guess I could have maybe gone to the '96, but it was, I think I was just, finishing up getting my new job and everything. So it came a little bit late for me.
Okay.
But yeah, it's
well, I
been every year.
It was a joint effort of the chairs and former chairs of the conference. I think we were all involved in it. Tom Spiro and I and Jay Groves and Brian Hoffman and Paul Saltman and all of the above. We always had a chairs meeting, as you know, during the conference, and this came up several times during the late 80s and 90s, wringing our hands and saying, how can we get young people in here? And so we said, well, how about a Gordon Research Seminar? How's that, where we'll only have young people speakers? And we tried it, it worked. It's interesting that we're the only Gordon Research Seminar that has the seminar before the Gordon Conference. Nancy knows this very well, that all the others have their graduate research seminar after the regular Gordon Conference. And I think I'm pretty sure Nancy is going to force us to adhere to the regular system. But
Harry, I'll
switched around.
Respectfully disagree, because I went to one of these for inorganic chemistry, and it was before. So whatever you were able to do with regard to having the seminar beforehand has been adopted elsewhere.
Yeah, ours was always, our GRS was always after our GRC with the shared Thursday night, remember? But now we're switching to the other format. Yeah.
Ours is always after.
Oh, okay.
Yeah.
Because we have ours is always after, because we have the joint Thursday meeting and where everybody mixes it up. And we thought that was a good model, but all the others now, if I'm not mistaken, have theirs before the conference.
Yeah, so we're switching. Yeah, so I got some information from Nancy. She said that there will be 187 GRSs in 2022, which is awesome. And she said that the growth of the GRS program started in 2005, based on the success of the bioinorganic GRS going back to '96.
Yeah, okay, great. Thank you, Nancy.
Yeah. The other thing I just wanted to remind all participants that you're welcome to participate in questions and answers through the Q&A tab on Zoom. So please put your questions and comments there. And I do have a relevant one here from Partha Basu, who says that he attended the first GRS and that Joan Valentine's student was the chair. So I was trying to I was wondering who the chair of that first one was, and I didn't know who that was, but it was someone from the Valentine lab. So
It could have been Allison Butler.
Not sure. So
Allison worked with Joan Valentine and postdoc with me.
yeah, it was not Allison. Oh, it was Ed Ha, Partha says.
Oh, it was, okay.
Yeah. So I have another question, if it's okay, we go on to another topic. Jim McCusker has a question asking if you each can share with us an example of a result that you saw at a Gordon conference that changed your perspective on the field of inorganic chemistry.
Well, sure. Rich, you want to take that first?
I can certainly, I covered some of that in the talks because they involved the conference that I was chair of. So that was a long time ago. I think at that time as well, all the interest in terms of CH activation was going on. And there had been specific examples of this, both from my colleague Bill Jones and from Bob Bergman. And at the same time, I was listening to Jack Halpern do the analysis that seemed to suggest that it was impossible thermodynamically for CH activation by metal complexes. And so I think that really influenced in part the thinking in there. We spent a lot of time talking about that. So that's one. Harry? Yeah.
Jim, I've had several very interesting presentations that really changed my perspective on the field. Very early on, it was the work that was done on inert gas complexes. That really changed my way of thinking about bonding and in complexes, the fact that you could make a xenon tetrafluoride. And that was very early in the 60s. And then the business about all the discussions of electronic structure in the 60s, and where people were inventing new ways of doing it, and the conversion into high-speed computation, in which people were adding more and more electrons to computation. I would say over the years, all the talks in theory have changed my view of how much you could do with theory in the field. I had started some theory myself, but I was not that convinced that theory would do very much for the field, not as much as good experimental work, but I've changed my view of that over the years. People have done better and better theory to connect with experiments. And so many of those have occurred at Gordon conferences. Yeah. And of course, when people did the first membrane protein structures, that changed my whole view of what could be done and how much we could learn from high resolution structures from membrane bound systems. And in in photophysics, work that you know very well, people inventing picosecond and femtosecond experiments really changed my view of what could be done, and looking at reactions, excited state reactions in very short timescales, and how much we could learn from that. That definitely affected me and got me more into photophysics. So those are just some of the many things, but I can tell you, Gordon conferences, I've always gone away from a Gordon conferences with some 2 or 3 new ideas that have come about because of talks. So there are really too many, Jim, to name of how I've been influenced by talks given by people at Gordon conferences, where they say, in the spirit of the Gordon conference, in the spirit of the Gordon conference, I'm going to speculate on something and tell you something that I haven't had the courage to publish yet. And of course, that's one of the highlights of the Gordon conferences, is people talking about unpublished work, and the people in the beginning saying, you know, you can't talk about this outside without the permission of the speaker because it's unpublished. And so all of those events of people talking about their unpublished discoveries have affected me.
Yeah. Jim, I have one other point to make is that we have gone to contractor meetings, sponsors, DOE, and in certain ways, our meetings are informal and have aspects that I think have been adapted from the Gordon conferences. They're successful, but not as successful because they lack the informal hours, and everybody feels the informal hours that the GRC'S offer. And what's more, it's put on by the person that is, or the organization that's supporting you. But I like the idea of the smaller conference, and I think that the contractor meetings emulate a little bit of that in the of the Gordon conference. Just there isn't this informal discussion time that really is successful.
Rich, I'd like to ask you what you don't like about the PV electrolyzer.
Well, it's not that I don't like them. The fact is it's a whole different model. And I like competition between ideas. And one of the aspects there is that if you do PV electrolyzer, you have, let's say, solar arrays, you're generating electricity, and then the question is how good, how efficient, how cheap is the electrolyzer to do? At that point, you're stuck with your hydrogen and your, let's say you let the oxygen go. It's a question of how do you take that hydrogen and deliver it wherever it is that you want to do.
Yeah, my point is that there have been such incredible advances in photovoltaics by applied physicists.
Absolutely.
So
Absolutely.
now they're readily available, they're relatively cheap. Electricity from sunlight is almost free now. There's an abundance of it everywhere. And there have been such incredible advances in electrocatalysis, separately in electrocatalysis of water splitting and carbon dioxide reduction. And the devices that combine all of this are very, very complicated and hard to fabricate and have many issues. So I think we have to start with PV electrolyzers, at least in the next 10 or 15 years, in order to get this solar fuel stuff off the ground.
Well, I think Harry,
that's my point.
Yeah. Okay.
My point is we can do that right now.
Fine, let's do it. I mean, we do have let's say, a very limited number of hydrogen fueling stations in California. Japan has made a tremendous commitment with regard to fuel cell cars, which in turn is going to require distribution of hydrogen. I'm not saying that the PV electrolyzer model is not as good as the water splitting model. They are related. Let's do the science. Let's have the stimulation and continue on.
Yeah, well, of course, Germany has shown that you can do solar, quite widespread solar, even in a country that doesn't have the sunlight that California has.
Mm-hmm.
So I know you're stuck in Rochester and it's weather's always bad. And actually, you're in Florida now. I know that.
Harry, it's not a question. It's not a question of one approach will negate the other. It's a question of let's allow the two, the science involved in both develop further. And then let's allow the implementation, the engineering, and eventually the economics determine what will be the more successful model.
Let's get Kara to break the tie then. Which way will you go, Kara?
Well,
You're a big solar, you've
here.
contributed a lot to solar now. Which way will you go?
Well, I think in energy is a big problem, and we generally need an all of the above solution. And I can say that without having to take sides also.
I see there are quite a few
Yes.
questions in the Q&A now.
Yes. Yeah. So I was hoping to get to some of those. So here's a great one from a student. And I actually might be able to take a crack at an answer to this as well. So this is from Niharika Bocha. I'm sorry if I didn't get your name correctly. So
where is she?
This says I'm a PhD student.
Where is she?
Just a PhD student. The question doesn't say where she is,
Okay.
but she's a PhD student. She hasn't gotten to attend a Gordon conference yet. Her question is, how does a young chemist not be intimidated at the GRC, mixing with all the elites in the field? I'm always nervous and excited whenever I talk to seniors and experts in my field. How is your experience? And I can actually give one initial answer, but we want to hear from you and Harry and Rich. One suggestion I would have would be most GRCs have associated with them this Gordon Research Seminar, GRS, that occurs beforehand. And if you go to the GRS first, you get to present your data there, discuss with people who are also early career scientists. And then that is a really great warm up for then going into the GRC. You've gotten to try out your ideas, have some discussions, and then you can then start to mix with more senior people in the field with more confidence.
Kara, one point is that there are some more senior scientists that are also going to the GRS. They're giving talks, they're interacting, and it is a way to begin this process. And the other is that with regard to the GRCs themselves, those pictures of discussions after the formal sessions, I think that says it all. You really develop interactions, friendships, and stimulation scientifically that carries you for months and years.
Yeah, well, my formula for this is be sure to go to either the GRS or the GRC. If you go to the GRCs, be sure to present a poster.
Yeah.
And have your poster ready. And what you'll find is a bunch of these senior people will come by and talk to you and ask questions. And what you'll find out is these senior people actually aren't very intimidating. They're pretty friendly, and you'll get to know them this way if you present posters. So the combination of doing things at the GRS's and presenting posters at the GRC's, you'll find that you'll become very comfortable talking to senior people, because senior people are very anxious to talk to young people. They're in the business of recruiting young people to grad schools and postdocs and things like that. And so you'll occasionally run into some jerks and so forth and you can get rid of those pretty fast. And but 95+% of the so-called big shots at meetings are really pretty normal people who love to talk to young people. And you'll find that out if you get a poster.
I'll also say that actually you network with other people, peers, who are of similar seniority to you, meaning they're younger people, and you build friendships. And those friendships really carry you for many, many years. They're wonderful. I have lifelong friends like Bob Bergman and Maurice Brookhart and many others. And it just goes on. Bob Grubbs, another.
So my advice to you is, when you go to your first Gordon conference, walk up to some big shot and say, Rich Eisenberg and Cara Bren and Harry Gray told me to come up and talk to you and tell you that I like your work and some of it's probably wrong, so I'd like to discuss it with you.
That would work.
And then the ice will break and you'll have a lot of fun.
Yeah.
That's good advice. All right. So here's a possibly provocative question from David Eichhorn that I'd be interested in hearing. My colleagues in other disciplines are always surprised that a GRC in inorganic chemistry still exists. Most GRCs are much narrower in scope. Would you like to comment on that? What's the role of the inorganic chemistry GRC in the current day?
Yeah, well, success comes with real difficulties. And the Inorganic Chemistry Conference in the 1960s was so successful in bringing folks in and discussing current stuff and making such a splash that all of these other Gordon conferences split off from it. So the ones I discussed and others. So when Metals in Biology started, and Metals in Medicine, and the Mechanisms Conference, all the others left the Inorganic Conference wondering what should we be doing. There's all the Organometallics especially took away a lot of the regular stuff at the Inorganic Conference, and so did Metals in Biology. So the great success of Metals in Biology and Organometallics left the Inorganic Conference wondering what to do. And there were many discussions of this. And now they've come to the point where I think the Inorganic Conference specializes in various things at different meetings, and it's continued to be a vibrant conference. Although I think it went through a period where people wondered whether it should continue to exist, because all of these other conferences taken away a lot of the glamour. But the chairs of that meeting figured it all out and decided to specialize in areas each time, put emphasis on a certain area like solid state or materials or catalysis and so forth, and managed to re-energize the Inorganic Conference to the point where today I think it's going great.
Yeah.
But it went through a period, you're quite right, it went through a period of self-examination.
I think that the problem that happened is you would schedule, let's say, all the materials talks in one session. you'd schedule the theoretical talks in a session. You weren't mixing it up. And I think that this is where Harry has raised the point, and they have addressed that. So I think that there's a vibrancy with regard to the inorganic GRC that does exist with the others as well.
All right, here's another question from someone I know you know, Bob Bergman is asking, can you comment on the effect of changing hour-long talks to half-hour talks, allowing more questions and a larger number of speakers? And I don't know when that happened. I think that was before my GRC time, but.
I'll take that one because at least beginning, I know Harry will have comments, but we used to have 3 long talks in the morning and then 2 long talks in the evening. And it was not good. When I ran the conference, we went to shorter talks. And then the following years, I think Henry Brinza and Tom Baker started with poster talks, or maybe it was Bob Bergman that did. But basically, the shorter talks and young people coming with their posters and submitting their posters for presentation. There was periods set up in the program to have 6 or so of these talks presented. All of this served to get a wider range and a more dynamic range of material presented. And that's I think when it first started, which would be around 1990s.
Well, in metals and biology, there's always been a tension about the length of the actual talk and the length of the discussion section. And there's always been attempt to make discussion sections longer and the regular talks shorter. And to some extent, and then having the last night with maybe young people talk after the main talk and so forth. And so that's been partially successful. I have to say that I've been to many, many Gordon conferences and of many different names. And the one that impressed me most about the business of getting young people involved in discussion sessions was the electrochemistry Gordon conference, which devoted a whole session to a whole day almost to people, young people, giving short talks and lining up to give short talks. And I thought that worked really, really well. So I'm for short talks. I'm for young people getting involved in short talks and for longer discussion sessions.
Yeah, John Dawson also had asked about the importance of the discussion session and having that dedicated time. And I think that is one thing that sets the GRCs apart, indeed.
Yeah, because at ACS meetings, there's essentially no time for discussion. If you went to the last ACS meeting in San Antonio remotely, as I did, every talk ended with the chair saying, well, there's no time for discussion. We have to move on to the next talk. So that's what differentiates the ACS meetings from Gordon conferences. And I think we have to keep working more and more to have shorter and shorter talks and longer discussion sections, because that's where people really pay attention. They pay attention after a regular talk when people are going back and forth exchanging views. And the ACS meetings just don't do that now. And Gordon,
I think, yeah, Harry, there's one other thing. I'll give a shout out to all the people that volunteered to handle the microphones, because the microphones going around ensures that somebody in the back of the audience can be heard by everybody in the room when they're asking a question. And you don't have that at ACS meetings and other meetings like that.
Well, you don't even have time for discussion at ACS meetings.
Yeah, so.
So it doesn't matter where the microphone is.
Yeah. And also the person asking the question introduces themselves. And that doesn't happen at other meetings as well. So everyone knows who they are, and it's really, truly a discussion.
You're right.
Yeah. So there was an earlier question. Someone asked who the one woman was in the 1951 Inorganic GRC, and I didn't know if either of you knew. So I asked the audience, and the answer is Edith Boldebuck.
Mhm.
So I don't know if either of you knew her, but I thought that that was cool that somebody knew who that was.
Yeah.
That's great, because I didn't know who it was.
Yeah.
Then
So
a related question. So Pernilla Wittgenstafstede has asked, so you both are famous stars in inorganic chemistry today. Do you use your visibility and influence to promote women in science and increase diversity? Your voices can be very powerful.
well, Pernilla, I've certainly promoted you. And I think your work is awesome. And if you look at my record with women working in my group who've gone on to be stars, such as you and Kara, and I could name 20, 25 others. I've certainly devoted my life to promoting women in chemistry and inorganic chemistry and bioinorganic chemistry. So I'm on board. I'd have to say that when I first started at Columbia, to give you my record, when I started at Columbia, as Rich well knows, it was Columbia College, it was all men. And the courses, the Columbia College courses were all men. No women were allowed to take those courses, even though Barnard College was part of Columbia University, and across the street, literally from Columbia and Havemeyer Hall, Barnard women were not allowed to take my advanced inorganic chemistry course, and Barnard did not have a course like that. The women at Barnard College came to me and said, Harry, we'd like to take your course. And I said, well, I'm going to see if I can make that happen. So I appealed to the powers that be at Columbia, the dean, whose name was David Truman, and the president, whose name was Grayson Kirk. And they said, sorry, Columbia College is for men only. And courses are for men only. And I replied by saying, my course is not offered at Barnard College, and Barnard women should take advantage of my course and learn some advanced inorganic chemistry, and they will find out that it's much more interesting than organic and physical chemistry, which is all they can get at Barnard. And so they relented, and the first Barnard woman to ever take a Columbia College course took my course. So Pernilla, I rest my case. And from that time on, I have devoted a lot of time to recruiting women and supporting women, as has Rich Eisenberg. And if more chemists would do that, we would be in better shape right now. There would be more discoveries and more great work. So I think everyone in the field has to work hard on diversity, not only women, but diversity in all aspects of diversity. That we can get to the point where our meetings are inclusive of everyone who wants to do science.
I'll second Harry on this. You know, the story that Harry tells, which is over 60 years ago, but the fact is that we have many more women, as you saw in the inorganic GRC. And it's a wonderful thing. And I think that people are much more sensitized to it, and we are moving forward with regard to that and the inclusion of not just women, but of different minority groups that happen to be ethnic groups now going into chemistry. This is a wonderful thing, and chemistry will be what binds us all together, our love of chemistry. And that's something that we have to continue to fight and push for. And
Well, Kara's an example. How do you view the situation now with women in inorganic chemistry, Kara?
Well, numbers are certainly increasing. You see it more among the younger, members of the community, right? There aren't as many senior figures as we would like to have in the field. Whenever we do a search for inorganic faculty, there's always quite a few more applications from men than women. Women, I don't think, are being as encouraged to apply for these positions and have a harder time seeing themselves in those roles because they just have fewer people that they can look to who they relate to, who do that kind of work. So I definitely see it changing, but it's really slow. So when I started here at Rochester in '97, I was one of 2 women. And I remember thinking, okay, I bet in 5 years, I'll have a bunch of female colleagues. I don't know what I was thinking, or 10 years. But it took about 20 years before I actually had, more than 2 women here on the faculty here at Rochester, almost 20 years. And so it moved much more slowly than I ever expected.
Well, Kara, it wasn't that there was any resistance to this. I mean, we know that 4 out of our last 5 hires were women, but it was making the system more accommodating to the specific needs that women might have that would be different than men. And part of this relates to families as well. In any case, I think the change is happening.
Mm-hmm.
I'm delighted it's happening. And we have to continue to push to make the environments favorable so that people can, women and any other groups can apply and have success. And I think we're being proactive, and I think many universities are being proactive right now at this time.
I'll just throw in one number for you. As Rich knows, there's an award in the ACS, a national award for creative work by a young investigator in inorganic chemistry. It's been going on, thanks to Rich Eisenberg and others, for the last 7 years. Of the 7 awardees, 4 are women, 3 are men. So I think that's making an important statement to where the young people in the field are right now.
Yep. Okay. So I wanted to, there's a couple other questions here I wanted to get to. So David Lacey is asking, you mentioned solar fuels already. What other societal relevant problems do you see inorganic chemistry playing a central role in?
Certainly the work on with inorganic catalysts and so forth, and that will degrade plastics that are piling up in our environment. Environmental cleanup, inorganic chemistry can play a big role in that, because we've got an enormous amount of plastic and garbage around the world that's piling up, and we have to figure out how to deal with that. That's one for sure, where I think inorganic chemistry and catalysts can play a big role. Rich, do you have a favorite?
Well, I would say it relates exactly. I had just jotted down catalysts, which would go exactly to what Harry is talking about. But also, if we think about the world and materials in a resource limited world, what kind of materials can we make? What kind of materials can we fabricate or use, and how can we use them? These are all questions that are important and essential to deal with. There's something as mundane as, let's say, concrete. And concrete is one of the big producers of CO2. What kind of structural material are we going to have that would take the place of concrete? Another, think about the metals that we use. And again, they're great producers of CO2 and how they're mined. What kind of materials can we get that might substitute satisfactorily? I can't tell you what they are. They're there to be discovered potentially. And those are the kinds of things that I think need to be addressed during this century.
Yeah, well, my answer to this is when I give talks about the importance of inorganic chemistry on planet Earth, I usually start by saying there are three enormous problems in the 21st century that chemists, and inorganic chemists in particular, have to take on. They involve energy, number one, number two, environment, and number three, human health. And inorganic chemists are positioned to make major contributions to all three of these most important issues in the 21st century. On energy, you've already heard about from Rich. On environment, I mentioned one, but there are many others. And the one that's missing from the discussion up to now is human health, where inorganic chemistry and the drugs that have come from metals and medicine, starting with the platinum drugs for cancer, and all the others now, I think traditionally we've had the pharmaceutical companies dominated by synthetic organic chemists and organic drugs, organic chemistry drugs. But I think the future looks like it's going to be dominated now by inorganic and metal-containing compounds. And so that's another huge area for the field of expansion of the field. So I hope that gives you enough motivation to stick with inorganic chemistry.
Great.
Okay, Kara, you
I
buy
have another. I buy it.
Okay.
So I wanted to get to another question asking for some career advice. So this is from Holly Redmond, and she says, Harry, it sounds like you've changed fields quite a lot, organic to inorganic to photophysics. I'm interested to hear if you experienced challenges doing this. How do you overcome them? And she's asking all of us if we have advice for anyone who might be going through a career transition, PhD to postdoc, postdoc to independent.
Well, I think it's, well, in my case, I'm just a very curious person, in inorganic Gordon conferences and metals and bio, all the conferences I've heard talks that intrigued me to go further into other fields. It's a partial answer I gave to Jim McCusker. But I found the transitions really fairly smooth because of my early background in inorganic chemistry and the fundamentals. If you really do a lot of work in the fundamentals of mechanism and theory, ligand field theory and so forth, you can find, if you've done that training, it's much easier to go into the more applied areas that build on these fields. And so I would make a plea for young students to make sure you get a grounding in the fundamentals of inorganic chemistry without immediately starting on something that is not grounded in ligand field theory or fundamentals of mechanisms. All the fundamentals of the field you can build on, But if you skip those areas and go into some, for example, biological areas, you go just straight into biological areas without having the fundamentals of inorganic chemistry, you'll miss a lot. On advice, I think so first bit of advice, be sure you get into the inorganic chemistry fundamentals of electronic structure, electronic structure, and mechanism, which I consider essential. Secondly, move around to different places. Don't stay in the same place. I think it's good to do your undergraduate work in one place, do your graduate work in another place and learn new things, and do your postdoctoral work in still another place, and get your first job in still another place. So you move around and learn a lot of new things, and you don't get into some stagnated system. But in terms of what you get into, you should get into things where you really love to do it. And I have a weekend test for that, which I've given in many commencement addresses that I've given at universities to young people. And it goes like this. If you're working in your chemistry work and you come to Friday afternoon and you decide that the thing you want to do most on Saturday on the weekend is to do something completely different, then you're probably in trouble. But if you, on the other hand, if you do chemistry all week and you can't wait for Saturday morning where you won't be bothered by anybody and you can concentrate on just what you really want to do and the stuff you're working on, then you found what you really love to do. If you fail my weekend test 3 months in a row, my strong advice is to change fields. You're really doing something that you don't like. And so that's my advice to you. And I'll leave now to Rich to tell me I'm all wrong about that.
No, you have to love what you want to do, but life sometimes doesn't allow you to do it unfettered by other obligations. One of the things
you can always flip hamburgers at McDonald's.
Well, yeah,
you can always be a bartender.
Well,
I've known a lot of bartenders, particularly around the University of Chicago, who were former PhDs who didn't like what they were doing. So that if you've ever been to Jimmy's, close to the University of Chicago, you'll see that there are a bunch of PhDs there that hated what they were doing. So they decided to tend bar at Jimmy's.
Yeah.
You can go to Jimmy's, by the way, and have some really interesting discussions.
Harry, I just wanted to add to into the question, which related to going to other postdocs. I think that one of the important ways of broadening one's base and expanding it is collaboration, and being able to get together with people who they bring a different perspective, a different background to the problem. And you acknowledge that I'm a dummy here, and that person acknowledges that I'm a dummy in that area. And then you teach each other and you work together. It's so you can broaden your base, not just by doing postdocs, but also you can broaden your base through effective collaboration. It's not always easy to do, and maybe there's some way that our system can be a dating service for that. But the idea of people looking to collaborate might be as effective as just taking on serial different postdocs as you go through life. So that's a suggestion.
My other advice to that person is please go to as many Gordon conferences as you can. That's where you
I'll agree.
That's where you will learn what you really want to do. If you go mix it up with people at Gordon conferences, because in all of the fields I have worked in, I've really been stimulated to get into those fields by discussions I've had with people at Gordon conferences. And so that's the best way to go.
Harry, Rich, and Kara, I just want to thank you so much for both your scientific insight, but mostly for what you have done to document the amazing and outstanding individuals, including yourselves, who have just advanced the frontiers of inorganic chemistry for 70 years. And we need to pay tribute to those leaders in your fields. The Gordon Research Conferences, our goal is not necessarily to run conferences, it is to create communities. And your talk today described how communities evolved from the grassroots efforts of the scientists that we're all trying to serve. So thank you so very much for sharing the story of the evolution, for honoring us with the kind of knowledge, insight, and advances you have made. We're just incredibly grateful to you for that insight.
I would like to say, Nancy, that you and your folks at the office in Rhode Island have been so supportive of all of us who have worked in these conferences and been chair of these conferences, and your training of chairs and your attention to detail has been just absolutely wonderful. And we can't thank you enough for all you've done.
Thank you so much, Harry. That's very, very kind. Our small but mighty team of staff members are very excited because the board has supported the relaunching of a mini season of Gordon conferences and seminars. This October and November, there will be 17 communities that will gather, hopefully in safe environments, to continue to advance the frontiers. And then in 2022, we're excited to relaunch our meetings. There will be 220 different communities and 187 seminars that will be held in 2022. And if anyone's interested, applications are being accepted through our website right now. So we're very excited to continue not only these events, our virtual component of the Gordon Research Conferences, but to return our communities to gather together and advance the frontiers. So,
if I could say one more thing, I see there's still some questions in the Q&A that we're not going to be able to get to because of time. So, Kara, I would say that we would, you and Rich and I will welcome emails with questions because we haven't had we're running out of time and we've got ones that are left. So if anyone wants to send us emails and ask us further questions, please do so. We would welcome that.
And if you don't have their emails, you can send them to connects@grc.org, and we'll make sure they get to Harry, Rich, and Kara as well. So again, thank you so much for your time, your enthusiasm, and just all your service. We're going to end with a short video in which audience members can give us feedback on the experience and also learn about how you can participate in future GRC Connects offerings. So thank you all again. We look forward to seeing you hopefully very, very soon. Bye now.
Thank you all for attending today's event. Very shortly, you will receive a brief survey. Please provide us with your feedback so we can continue to plan future GRC Connects events. In addition to the survey, you will have the opportunity to contribute to one of GRC's diversity initiatives. This helps us attain our goal of holding open, diverse, and accessible meetings. We want to thank those who have already made a contribution prior to the event. We really appreciate your support. Are you or your community interested in hosting a GRC Connects event of your own? If so, please reach out to connects@grc.org. And don't forget to follow us on all forms of social media so we can stay connected. We want to thank you all for attending today's event, and thank you so much to our incredible speakers. We hope to see you all very soon.